Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 is a multi-step question, and it is to calculate the number of atoms in the universe. The following steps will guide you through this calculation. Okay, so let's do this step by step. Part A. Planets constitute less than 1% of the total mass of the universe and can therefore be neglected. Stars make up most of the visible mass of the universe, so we need to determine how many atoms are in a star. Stars are primarily composed of hydrogen atoms, and our Sun is an average-sized star. So calculate the number of hydrogen atoms in our Sun, given that the radius of the Sun is 7 times 10 to the 8 meters, and its density is 1.4 grams per centimeter cubed. The volume of a sphere is given by volume is equal to 4 over 3 pi r cubed. So hint, use the volume and the density to get the mass of the Sun. Okay, so very helpful information. So for part A, first let's calculate the volume. So volume is equal to 4 over 3 times pi r cubed. So they tell us the radius of the Sun, which is 7 times 10 to the 8 meters. So let's plug that into our equation for volume. And if we plug this into like a calculator, you end up with a volume of around 1.44 times 10 to the 27 centimeter cubed. Okay, so now for part 2 of part A, I guess, is to calculate the mass of the Sun. And to do that, we would use the density equation. So density is mass over volume. And we want to calculate for mass. So we do mass is equal to density times volume. And the density is 1.4 grams per centimeter cubed. And the volume is what we found in the previous step. So 1.44 times 10 to the 27 centimeter cubed. Okay, so if we multiply these two values together, we get a mass which is 2.016 times 10 to the 27 grams. And this is the mass of hydrogen atoms in the Sun. Okay, so we know the mass of the hydrogen atoms in the Sun. Now let's try to figure out how many atoms this is. How many atoms of hydrogen are in the Sun. So in order to find the atoms, we first need to find the number of moles. So the number of moles is equal to mass over molar mass. The mass of hydrogen atoms was the 2.016 times 10 to the 27 grams. And the molar mass of hydrogen is 1.01 grams per mole. So now this gives us the number of moles of hydrogen in the sun, which is 1.996 times 10 to the 27, I think my note says. Moles. And now that we have our answer in moles, we can convert to atoms by using Avogadro's number. So if we multiply by Avogadro's number, which is 6.022 times 10 to the 23, and this is atoms per mole, we can get the number of atoms in the sun. So we end up with 1.2 times 10 to the 51 atoms in the sun. Okay, so part 2, or part B, the average galaxy, like our own Milky Way galaxy, contains 1 times 10 to the 11 stars, and the universe contains 1 times 10 to the 9 galaxies. Calculate the number of atoms in an average galaxy, and finally the number of atoms in the entire universe. Alright, a lot of big numbers that are about to occur. This is part B. And first we need to find the number of, or let me try to find the number of hydrogen atoms per galaxy. Okay, so first we need to multiply the number of atoms in one star times the number of stars. So back to our previous step, we calculated the number of hydrogen atoms in one star to be 1.2 times 10 to the 51. So I'm going to say H atoms per star. So now I just need to multiply this by the number of stars in a galaxy. So we have 1 times 10 to the 11. And then this is going to be stars over galaxy. So now we can get the number of hydrogen atoms in the galaxy. And this is going to be 1.2 times 10 to the 62 atoms per galaxy. Okay, so now we need to find how many atoms in the universe. So hydrogen atoms per universe, we need to multiply again. So now we have 1.2 times 10 to the 62 H atoms per galaxy And now we need to multiply by 1 times 10 to the 9. And this is galaxy or galaxies per universe. So now our unit for galaxies, I guess, will cancel out. And if we multiply the two, we have 1.2 times 10 to the 71 atoms per universe, which is a lot. So now let's look at part C. You can hold 1 times 10 to the 23 atoms in your hand. 5 copper pennies constitute 1.4 times 10 to the 23 copper atoms. How does this number compare with the number of atoms in the universe? Well, let's say there was the 1.2 times 10 to the 71 atoms per universe. Let's divide this by 1 times 10 to the 23 atoms that can fit in your hand. And you still get like a pretty high number. Maybe 1.2 times 10 to the 48 more atoms. It's a pretty large number to compare, therefore relatively large. Okay, so pretty long multi-step question, but we figured out how many atoms are in the universe. Let's compare our answer with the junior tutors. For part A, given the radius and density of the sun, we can calculate the number of hydrogen atoms in the sun as follows. First, we should get the volume of the sun, which is a sphere, by using the given radius and the formula for volume. So they got... Okay, I think they accidentally put the radius as 7 times 10 to the 10 instead of 10 to the 8. So their answer will be off by like a couple exponents in the end. But the work was correct. But they still ended up getting a 1.4, but their exponent is 10 to the 33. So we can just take note of that later on. The mass of the hydrogen in the sun can then be calculated by using density. So mass is density times volume, and they got 2.0, again, times 10 to the 33 is incorrect. Okay, so now they calculated for number of atoms. So the 6.23. So the units for Avogadro's number is not atoms per gram, it is atoms per mole. So they're just missing the step of when we need to calculate for number of moles. So again, number of moles is equal to mass over molar mass. So they're just missing that one step. But you can see that even though they forgot this step, by dividing by the molar mass of hydrogen, which is pretty much just 1, they get a similar value. But even then, it's a bit off because of the exponent. But still, I'll take note of that as well. So then for part B, they calculate the number of hydrogen atoms in one galaxy. So they multiplied 1.2 times 10 to the 57 in their case, times 1 times 10 to the 11 to get the number of atoms in a galaxy. And then they solved for the number of atoms in the universe. So then you multiply that value by 1 times 10 to the 9. And they got 1.2 times 10 to the 77. So again, it's pretty close. The only reason why it's a bit off with the exponents is because they inputted the wrong radius at the very beginning. C, the number of atoms that can be held in the hand, is almost incomparable to the number of atoms in the universe. Number of atoms in the universe is relatively larger than that we can hold in our hands. So that is correct. So I'll say most of the steps in the solution are correct. However, A in the initial calculation for solving for volume, the radius should be 1 times 10 to the 8 meters. And then B, before we multiply by Avogadro's number, which is 6.022 times 10 to the power of 23 atoms per mole, we need to calculate number of moles for hydrogen by using N is equal to mass over molar mass. The final answer should be 1.2 times 10 to the power of 71 atoms in the universe. Okay, so just some minor mistakes, but I think it's important to note that for Avogadro's number, the units aren't in grams per mole. Well, it's not grams per atoms, it's number of moles per atoms. So that's important to note as well. Or atoms per mole, sorry. But yeah, I can see how it can get pretty confusing.